Now I'm going to move into further discussion to this plasma air sanitization technology. And just to recap a bit, now basically we make, in this technology, we make use of a kind of electric field in the tube that will create high temperature plasma. One way to look at it, a simplified version to look at it, is we create thousands of these micro nitrogens. And you can imagine with the natural nitrogen is very destructive. If it hits anything, a tree, it can actually blow it up. This is very tiny, so it won't be as powerful as the naturally occurring lightning, but it is still strong enough that it can break down the microbes, therefore deactivating the virus. And it also works on the volatile organic compounds. Again, by breaking down those molecular bonds, you can break down toxic chemicals like the formaldehyde. Another important fact is that plasma may use the nitromycin kind of physical means to kill the germs. So it actually doesn't matter whether those pathogen is big or small or mutate or not, because we are using physical means. Unlike biological means like medicines, when we need to treat a certain or fight against certain virus infections, you need to have the correct right kind of medicine for it. Whereas physical means, or you can look at it just like an electrocution. We simply just destroy anything in the path of a micronitrogen. And again, everything happens within the ionization field, within the device itself. And it can't happen outside, because you definitely need the electric field to maintain the energy level of the plasma. So if you compare to other technology, you'll find that it is many, many times faster. And since it's not based on filtering, unlike many typical technology machine that usually rely on filter, and that needs replacement. Now, even though in principle, we can, using plasma to kill all kinds of germs, pathogens, we still need to verify it. So we have done tests in the past together with microbiologists from the Hong Kong University as well from the City University. And we have tested over almost close to 20 different species. And here's just a summary of what has been tested in this table. For virus, we tested against one of the influenza virus, H3N2. This is the common Hong Kong flu virus. And fungi, we have tested against a few typical ones. These are the ones that are most prominent in causing allergy. People having allergy problem. Sometimes they will have all this running nose, red eyes. Often there are many, first of all, for allergy, there could be many different reasons. Some may be more sensitive, let's say, to pollen, dust. Other may be to chemicals. But there are some people that are very sensitive to some fungi. And these are the ones that will cause them the most problem. The bacteria are the most common kind of germs that will cause problem, like E. coli, like the Legionnaire disease. That's something that happened from time to time in a ventilation systems, when you have this bacteria accumulate there with suitable conditions, they can actually continue to multiply, and then all of a sudden they will spread out. And so the whole building would catch this Legionnaire disease. And I'll jump some of them, but I'd like to mention the tuberculosis. The TB has been treated very well with some of the vaccines. So basically, has not been a problem at all for the past 40 years, 50 years. But now, like all kind of pathogens, they can mutate. The TB has mutated, and there are cases of some mutated tuberculosis. Now, this time, from my understanding, is the mutation is not too kind of serious. It's too far from the original one. So it still can be kind of treatable. But if it become more serious, then this can be potentially a very, very serious problem. On this table, there's another one that will catch some medical professionals' eyes. This is called the MRSA. This is the drug-resistant strain. In many hospitals in the world, they are having this problem now. They have this MRSA in the hospital, and since it becomes so drug-resistant, there's none of those existing antibiotic, anything that can actually eliminate this MRSA. So it's quite a problem. So this all has already been tested that plasma technology can effectively treat all these kind of microbes. Now, another thing is that we need to be careful with any electrical devices is whether the device can generate ozone. Electricity can generate ozone. All electrical machineries, from the printer you use to, let's say, running a motor in your vacuum cleaner, all this can generate ozone. So it's important that any electrical technology relies on using electricity. We have to ensure that the ozone generation should be kept to a very minimal. And already mentions that it can handle the very kind of pathogens and in a very short time. That's one of the key things for the promise of plasma technologies is that it's powerful enough that you can achieve a high level of efficacy at a very short time. And you need that for air disinfection. Now imagine that if you use something like UV and apply it to a normal air sanitization application, since if you look at the typical situation that you need 2 hours radiations, it won't work for air sanitization. Because for a sick person, let's say I'm a sick person, every breath I'll bring out some germ into the air. So if the UV system takes 2 hours to treat my first breath, that means there are 2 hours that this germ can accumulate in the room. So basically UV on this is the typical UV application is too slow for air sanitizations. Now, you can actually use a very, very powerful UV. There are some laboratories actually use it. They have very UV system in the lab. They will turn it on after working hours when you don't have any people in there, because if you want to shorten the radiation time, you need to increase the radiation, the intensity of the UV light. Now, that could be serious if you have people working under a strong UV. It's quite damaging. So in certain applications, yes, you can use very, very powerful UV to achieve some form of disinfection. And since UV is generated kind of indirectly in the plasma process, when we talk about UV tube, the fluorescent tube, and the overall efficiency it's actually lower because you're kind of relying on a secondary mechanism. You're not killing the germ using the plasma directly. You're using the UV light that's generated in a secondary process. So we are talking about, in terms of power efficiency, for a given kind of flow, meter cube hour kind of airflow, if you want to achieve the similar level of disinfection, we're talking about a power consumption for plasma power about less than 0.2 watt. Whereas for UV, we're talking about at least 2.4 watt. And at that level, you probably won't want to stay in that room. Now, here are some testings that have been done for a plasma technology-based air sanitizer, ranging from SGS testing for the removal of bacteria over 97%. Now here, I also want to talk about how tests are being done, and sometimes the differences in so-called the actual performance. If you look at the commercial market, very often the air purifier manufacturers will portray the machine is able to remove germs over 99%. But that's only a partial story, because you do need to understand the number they obtain in terms of this efficacy removal rate, how this was done, what kind of conditions. Usually, things that would affect the overall performance is the room size and also the time. So you could achieve a very high figure by putting your device in a very tiny space, a small box, or treat it for a very long time. You're talking about maybe 10, 24 hours. So that won't reflect a real performance in realistic applications. But that's, again, one thing that we need to be careful when we read over the test result report, when people advertising how much germs are being removed. So look into the number when this test was done, how large was that test chamber and how long it took. And here are then the summary of some of the test results from the University of Hong Kong and City U on the various kind of microbes. Now, the technology had also been tested in one of the hospitals in China, in Guangzhou, and it's done by the Hong Kong, by the China CDC, the Center for Disease Control. In mainland China, there's actually a standard for air disinfection in hospitals, and certainly plasma technology can perform and meeting those requirements. And on the lower right-hand corner is another test on the, again, risk performance on the plasma technology and the level of efficacy it can achieve. Another thing that we need to look at is the ozone production. Now, 50 parts per billion is basically the common reference for most countries, that in an indoor environment, ozone level should be less than 50 parts per billion. Otherwise, it will become irritating to start with and also could be damaging. I can see some questions here. Okay. Yes, when asked whether pump is needed to make air go through the tube, yes, it does. In a product design, of course, the tube only provides the generation of plasma. We do need a pump or a fan, in this case, to drive, to bring the air kind of circulating through the tube. The question is on the where you can disinfect all this on this list. Yes, it's been tested. These are the list of microbes that have already been tested. The plasma can effectively eliminate them, to deactivate them. Okay. I hope I didn't miss any more questions, so I'll move on. Yeah, if you have any more questions, please just send it over this chat board. Now, those test report certificates were done in a kind of laboratory environment. One may wonder is that, can you actually improve the living environment, reducing the cross-infections? So we spent 2 years in a case study in an elderly home. It's called Sintindo in Shatin, actually not too far from here. And over these 2 years, we recorded the number of flu infection cases and compare this number with the 2 years before they used this plasma air sanitizers. The photo here shows the placement of this air sanitizer in the kind of the common areas in this elderly home. The results indicate there was a reduction of 60% during the influenza season in Hong Kong. This would mean the period around from late November to around February time. And as a result, there were no more quarantine at this elderly home. What happened is that in Hong Kong, there's a guideline that if there are over a certain number of the residents in the elderly home got the flu, they infected with flu, they will have to basically quarantine the elderly home. What it means that the residents there are not allowed to go out and no more visitor can go in. So they're trying to isolate them and give them a chance to kind of heal by avoiding any more further cross-infection. But with the air sanitizer being used to help removing the germs there, and they already reduced some 60% of cross-infection. So they meet the guideline, they don't need this kind, or they don't need to exercise quarantine during this period.